After the release of full DeepSeek V4, after seeing the amazing benchmark results, which puts it on par with GLM 5.2, I did an impulse purchase of more DDR4 RAM to upgrade from 96 gigabytes to 128 gigabytes. So it's dual channel. So I get a 3200 MTS, which is about 25 gigabytes per second. I have a 4090, so get 24 gigabytes there, and I have a Tesla P40 that gives me another 24 gigabytes. And so that gives me a total of RAM and VRAM combined of 176 gigabytes. If I remove 20 gigabytes for Windows, that gives me 156 gigabyte of usable RAM and VRAM. So I've downloaded the DeepSeek V4 Flash Q4 XL quant, which is about 144 gigabytes. I'll run this and see how it goes. So DeepSeek V4 Flash is now running locally on port 1234, and it's using around, I've got only 2 gigabytes left on system RAM, and on GPU it's using about 17 gigabytes, and it's using 17 gigabytes of memory from RTX 4090 and about 21 gigabytes from Tesla P40. So I've configured it locally as an API provider, DeepSeek for V4 Flash on 1234. Let's run an inference against it. So I'll run the script to review this batch script file. And this is the bot I'll run against. The time to first token is going to be super slow, so I'll cut till when it starts responding. First progress is done 41% on processing for about 5,000 tokens, and it's doing 29 tokens per second for prefill. So we have started generating tokens, and it's done some reasoning and it's starting to read this file. So the last one was request was 2.41 tokens per second for decode and 33 tokens per second for prompt processing. And this is running DeepSeek V4 without the DSpark MTP. So to give an idea of the speed, that's how it looks like. So it's almost like one word about each second. And this is without the MTP. And given the MTP is about 10.5 gigabytes, even with 175 gigabyte combined RAM and VRAM, I cannot run the DSpark because I'm already full on VRAM and RAM. Mainly because I'm on Windows. If it was Linux, probably I'd be able to do it. And as you can see, it's mainly running off the CPU. GPU is being used, but not as much. Mostly running off the CPU. And we mostly getting around 2 tokens per second without the MTP. I've stopped the generation, and on average it's 2.24 tokens per second. So next I downloaded the IQ4 XS quant, which is about 127 gigabyte compared to 144 for KXL, and this should give me a bit of space to be able to run the DSpark MTP. But before we get into that, I'll need to show how I got this to working with Tesla P40. Initially, I had downloaded Llama CPP a CUDA 13, but the Tesla P40, the max it can support is CUDA 12.4, luckily. So I downloaded NVIDIA driver for Tesla P40 that supports CUDA 12.4. I installed this, but what happened is my RTX 40 was not installed, so it stopped working. So I tried to search for driver for RTX 4090, and you cannot search by CUDA version, so you could just search by your graphics card. And I need the same version as the Tesla P40, which is 553, but the oldest I could find here is 591.44, which is not CUDA 12.4. But I was able to find 55.1.23 for both RTX 4090 and Tesla P40. So I downloaded both, and then I installed the Quadro version first and then the desktop version second. And then I downloaded the Llama CPP CUDA 12.4 version. So this allowed me to run DeepSeek V4 Flash with CUDA 12.4 using RTX 4090 and Tesla P40. And next I'll run the script for IQ XS with the MTP of DSpark enabled to see how that performs. So now I'm running DeepSeek V4 Flash using 65K context size and using the DSpark MTP. It should be somewhere here. Yep, so it is loading the DSpark, and let's do some inference against it. So I'll go to the prompt, running again. I'll cut it when it starts generating. So I use DeepSeek over the API, the Flash version, the new version, to generate me this batch script to be able to run Llama CPP. The issue was that, so the way I wanted for it to happen was that the first layer to go to RTX 4090 and the last layer to go to RTX 4090 as well. Because if I believe if I put the first layer onto RTX 90, it does the prefill on that. And the reason I had to do the last layer as well on RTX 90 because there were some CUDA operations that the NVIDIA P40 does not support. So from layer 0 to 6, they run on Tesla P40 and the rest on the CPU. For the DSpark, I'm using min draft and max draft of 5, which is excessive. I think the best is 3, but I just wanted to get the most out of it because this is actually running on RTX 4090, so it should be quicker to generate. So the more I can generate of a draft tokens, the better it is for me. So it has generated starting tokens. So it's still doing around 30. So here it's doing 30 prefill, 30 tokens per second on the prefill, but the token generation is now around 4 tokens. But it depends on the context. So it can go from 2 tokens up to 4 tokens. So that is a big jump, given that the base is 2 tokens. So 4 tokens is almost double for my setup. Even then, I think it is very slow for agentic use. So here how it does look when it's thinking. Okay, so now it's calling a tool. Looking at the first request, time to first token, there was 5K token for the harness context window, and it generated 84 tokens. So it took around 184 seconds in total for the prompt processing and generation as well. So around 3 minutes. Here we look at the draft acceptance rate. So it's around 80%, and then 70, it drops off quickly. Even with the MTP, it's mostly CPU doing most of the work. The utilization of GPUs is a bit higher, but it's still not ideal. So here we can see the tokens being generated using the MTP as well. So it's around 2 words instead of 1 word every second. So on CPU DeepSeek V4 Flash, the public version, not the preview version, is usable if you really have to, but it is really slow, even with the MTP. So here we can look at the tokens per second. With the MTP, it bounces off from 2.4 seconds, sometimes 4, and even goes to 0.9 because there is an overhead for MTP. Well, roughly, I think it's around 3 tokens per second on average. So that's it for this video. I hope you find it useful if you think you're not doing a similar setup. Thank you for watching.